number 13, we're evaluating another integral. And we're going from 0 to 1, and we have the integral x squared square root of 1 minus x squared dx. So for this one, again, we don't really want to use u substitution here because it's not going to work out exactly how we like when we do the du and dx switch, because we would have a single power of x, but we have an x squared out there. So instead we want to use trig substitution. So since we have 1 minus x squared, we're going to use sine for x. And since our constant is 1, we don't need any coefficients, so we can just say x equals sine theta. Therefore dx is cosine theta d theta. So what we can do now excuse me, is have do our substitutions. So when we do that, our x out here becomes sine theta, and we have sine squared. Inside, we're going to have 1 minus sine squared, which would be cosine squared, and when you take the square root of that, you're going to get cosine theta. And finally, the dx would give you cosine theta d theta. So you can see when we put all that together, we're going to get sine squared theta cosine squared theta d theta. So when we have even powers of both sine and cosine, this is where we're going to use our power reduction rules. So the first thing that we can do, and the easiest one, would be to use the identity sine 2 theta is equal to 2 sine theta cosine theta. And if we rearrange that, you can see here that sine theta cosine theta is equal to sine 2 theta divided by 2. Now we have this squared, so we have this squared. So we can transform the integral, and I'll bring that 1/4 to the front. Sine squared 2 theta d theta. And now that we have it only as one trig function, we can use the double angle formula. So remember that for sine squared, so sine squared theta is going to be 1 minus cosine 2 theta divided by 2. But we have a 2 theta there already, so we have to keep that in mind. So this is going to be 1/4 from 0 to 1. We're going to have 1 minus cosine 4 theta all over 2. So we had to put a 4 there because you have to double the angle that's already in there. We can bring that 1/2 further out to be 1/8. And now we're just integrating 1 minus cosine of 4 theta d theta, which is a simple enough integral. So what we're going to get here is 1/8 times antiderivative of 1 is just going to be theta because we're doing this with respect to theta. So the antiderivative of cosine is going to be sine, but since we have a 4 theta, we're going to have to divide by 4. So we're going to get sine 4 theta divided by 4. Now that's from 0 to 1, but we need to substitute back in. Excuse me. So in order to substitute back in, if you notice, we have x equals sine theta. We have no way of doing that for sine 4 theta, so we're going to have to use our double angle formula twice to fix that. So let me erase this one here, and let me keep our one substitution that we had for sure. X equals sine theta. So when we have sine 4 theta, we can say that that is equal to, so we're going to have sine of, so we're going to have 2 sine 2 theta cosine 2 theta. So that's using the double angle formula for sine. And that is going to cancel that denominator to become 2. So that's going to cancel out that, but we have to do it again for each of these because we still have 2 thetas in here. So if we do that again, so sine 2 theta is going to be 2 sine theta cosine theta. Cosine 2 theta has a few different double angle formulas, but the reason that we want, since we have x equals sine theta, we want to use the one that only includes sine thetas, which is 1 minus 2 sine squared theta. That's all over 2, and now these 2's cancel out. So finally, let's substitute everything we can with x. So recall that if sine theta equals x, it means opposite over adjacent opposite over hypotenuse is equal to x. So we have x, 1, therefore this is going to be square root of 1 minus x squared. Okay, so we have, instead of theta though, we're going to have arc sine of x, because we don't have any other way of substituting theta. So now we don't have any fraction here because these 2's canceled out. We can just substitute everything. Sine theta is x. Cosine theta is square root of 1 minus x squared. By using that triangle, we have adjacent over hypotenuse. And this sine theta is still just x, so we have 1 minus 2x squared. And this is all from 0 to 1. So now we can just plug everything in. You can see that if you plug in 0, this is going to make this whole term 0, and arc sine of 0 is 0, so we're going to get 0. We only need to plug in 1 here. So we're going to get 1/8 arc sine of 1 minus 0. So finally, when we're down here to 1/8 arc sine of 1 minus 0, arc sine of 1 is saying sine of what is equal to 1. That would be pi over 2. So here we get 1/8 times pi over 2, which is pi over 16. So pi over 16 gives us answer choice